Great morning or afternoon, ladies and gentlemen. So happy you could be here today. You should have 1.2e lesson, 1.2e classwork open on your screen. We're going to be abstracting the solving process part 2. Last time we looked at this, we had gotten rid of the numbers and just were dealing with variables. And today we're going to be doing the same thing. So let's look at the directions for number 1. We're going to solve the following equations for x. Explain your solving process and assume no variables are equal to 0. Remember, we can't have variables equal to 0 because then if we ended up dividing by them, you can never divide something by 0. It's undefined. So let's take a look at part A. I want to look at two methods. So let's look at method 1. Method 1. The first method what I want to look at is when we first combine like terms. So when you combine 2x and 3x, you get, that's right, 5x. 5x equals 15, and then to isolate the variable, I'd undo the multiplication by dividing by 5 on both sides to get my final answer of x equals 3. Let's look at what that means when we combine like terms. When we're combining like terms, if we look at method 2, when we combine like terms, what you're doing is you can say that you're factoring out the common factors. So what's a number that's a factor? And remember, factors are numbers that multiply to make the number. What's a number that multiplies to make 2x that also multiplies to make 3x? That's right, x. X times 2 plus 3. Because x times 2 is 2x and x times 3 is 3x equals 15. You can also think about this as when we're combining like terms, we're taking 2 and adding it to 3 to make the coefficient of x. Now we're going to do the same thing. We're going to undo the multiplication by dividing both sides of 2 plus 3. And we know 2 plus 3 is 5, so 15 divided by 5, x equals 3. So let's take a look at this when we don't have coefficients, but we have variables instead. Remember, we're solving for x, so I'm going to circle what I'm solving for. And if I look at this with method 1, and I combine my like terms, remember when you're combining like terms, you're combining the coefficients and we're adding. So that would be a plus b all times x equals 15. Notice method 1 and method 2 are the same in this instance because we can also look at this as we're factoring out the common factor of x. What number is multiplied to make ax and can multiply to make bx? X. X times a is ax and x times b is bx. Now remember, since I'm isolating x, it's being multiplied by a plus b. So I'm going to divide both sides by a plus b. And when I do that, I end up with x equals 15 over a plus b. And that's my answer. So I'm going to do a few more with you on 2 through 7, and then I'm going to give you some time to work with your groups. So taking a look at number 2. When I'm looking at number 2, we should read the directions. Solve the following equations for x if a, b, c, and d represent real numbers not equal to 0. Why can't it equal 0? Oh, that's right, because if we divide by 0, we'd end up with an undefined value. So taking a look at number 2. When I take a look at number 2, what I realize is I have two ratios set equal to one another. Because I have two ratios set equal to one another, I've formed a proportion. How do we solve proportions? That's right, cross multiply. So when I do that, I have 2 times the quantity of 5x equals 4 times the quantity of a minus b. What variable am I solving for again? Oh yeah, that's right, x. 2 times 5x is 10x. 4 times a is 4a. 4 times negative b is negative 4b. How do you undo multiplying x by 10? Dividing both sides of my equation by 10. So there's two ways we could write this answer. We can say x equals 4a minus 4b all over 10. Or if you notice that 4 and 10 all have a common factor of 2, we can say that x equals 2 times the quantity of a minus b all over 5. We need to factor out the 2 first before you can, the 4 first before we can simplify, because you can't reduce when you have subtraction going on. So this middle step was saying that x is equal to 4 times the quantity of a minus b all divided by 10. And then you said 2 goes into 4 and into 10. Awesome. Let's take a look at number 5. When I'm looking at number 5, I remember that I need to be solving for x. When I'm solving for x, I notice I have x's on both sides of my equation, and I need to get them on the same side. It doesn't really matter which side I bring them to, but I think it's going to be most efficient to bring the bx over to the ax. So I'm going to subtract bx from both sides. And when I do that, I end up with ax minus bx equals c. I need to isolate x. Do you notice that x is being multiplied by both of those terms? Let's factor out the x. If I factor out the x, because it's a common factor in both of them, x times what gets me ax? X times a. Minus x times what gets me bx? X times b. Equals c. Now all I have to do is undo multiplying by the quantity of a minus b by dividing both sides by a minus b, and I end up with x equals c over a minus b. It's so nice I don't have to worry about making mathematical errors with numbers. Awesome. So what I would like you to do is I would like you to finish 3, 4, 6, and 7, the rest of this page, in 10 minutes. That's about 2 minutes per problem, a little bit more, working with your groups, not working ahead of your groups, and please put 10 minutes on the timer. Please put 10 minutes on the timer, and in 10 minutes we'll review our answers. Thank you. Okay, let's see how we did. And hopefully we paused the video for long enough. Let's take a look at number 3. When I was looking at number 3, I noticed I needed to isolate my variable x. So the first thing I wanted to undo was multiplying by the quantity of a plus b. So I divided both sides by a plus b. I could have dealt with the 1/2 first, but I didn't. So then, since I have 1/2 x equals c over a plus b, to undo multiplying by 1/2, I divide by 1/2, which is the same thing as multiplying by its reciprocal 2 on both sides. So your final answer is x equals 2c all over a plus b. Awesome, let's take a look at number 4. Looking at number 4, the first thing I wanted to undo was multiplying by negative 3/4. So I multiplied both sides of the equation by the reciprocal, negative 4/3. When I do that, I had negative 4/3 c equals xb. To undo multiplying by b, I multiplied both sides by the reciprocal of 1 over b to have my final answer of negative 4c all over 3b. Awesome. Let's keep going to number 6. Number 6. So 6, I was looking at this 2 different ways. Let's look at the first way. The first thing I saw when I was looking at 6 was I wanted to undo multiplying by a. I can't go into those parentheses until I undo multiplying by a on both sides. Then I undid the positive b by subtracting b on both sides. And finally, I had to make sure I was solving for positive x, so I divided both sides by -1 or multiplied everything by -1 to get 4d all over a plus b. Some of you might have solved it slightly differently. Some of you might have solved it slightly differently if you distributed the a first. Then we had to subtract ab on both sides. Then divide both sides by -a. And when you do that, remember a negative divided by a negative is a positive, and that's how you get 4d plus ab all over a. Awesome. Last one, number 7. Number 7, the first thing I wanted to look at on number 7 was factoring out my common factor of x. When I did that, I noticed that since x has a factor of x and -ax has a factor of x, when I pulled x out, x times 1 is x and x times -a is -ax equals 2 plus b. Undo multiplying by the quantity of 1 minus a by dividing both sides by 1 minus a to get my final answer of x equals 2 plus b all over 1 minus a, which cannot be simplified any further. Awesome. Great job. Let's take a look at number 8 and number 9. Looking at number 8 and number 9 together, taking a look at number 8 and number 9 together, when I'm solving, I need to remember which value am I solving for. Oh, that's right, I'm solving for x. Notice I have x on both sides of my equation, so I need to bring them to the same side. I'm going to add ax to both sides. When I add ax to both sides, what am I left with? Oh, 4x plus ax equals c. What am I solving for again? That's right, x. Hey, do you notice that both terms have a factor of x? What can I multiply to get 4x that I can also multiply to get ax? X. So let's factor out x. X times what is 4x? X times 4. X times what is ax? X times a. Now all I have to do is undo multiplying by 4 plus a by dividing both sides by 4 plus a to get your final answer of x equals c all over 4 plus a. Great. Let's take a look at number 9. Number 9, looking at 9, I'm noticing that I have an x plus d in the denominator. It's being divided by x plus d and an a over here. In order to solve this, what I'm thinking about is I would really like to have this as a proportion, so I'm going to write the denominator of 1 under the a. And then I have a proportion, so I can cross multiply. A times the quantity of x plus d equals 1 times the quantity of xd. Okay, do you think I should distribute the a, or should I just undo the multiplying by a? What do you guys think I should do? Any ideas? I feel like distributing today. So let's distribute. And I'll get ax plus ad equals xd. I need to get the variables all on one side. I have an x over on the right and an ax on the left. I'm going to decide to subtract ax from both sides. When I do that, I get AD equals, I'm going to rewrite this as dx, multiplication property, commutative property, minus ax. And I notice I have a common factor of x. So I'm going to rewrite this as AD equals, x is a factor of both these terms, so x times what is dx? X times d. X times what is ax? Negative a. I'd like you to finish solving this one, and I'm going to give you 1 minute to finish. 1 minute, finish solving 9. I'll check in with you back in 1 minute. Please pause the video for 1 minute and we'll be opening the next video. Thank you.